thank you very much for being here with us in the room in Brussels, but also online. We have nearly 300 people online following our policy workshop this morning. Oh, 74, oh, sorry. But 300 registered anyway. So I'm Susan Reinders, and I'm the leader of the ORCaSa project, which aims at really setting in place the Soil Carbon International Research Consortium. So today we will focus on one specific subject, which is how to measure, report, and verify soil carbon stock changes. And we have a panel sitting here in the front of experts from the US and from Australia, and of course from Europe also on that topic. So thank you very much again for being here, and we will start right on. Okay. Non, ça passe pas. Okay, next one. So this is the agenda of our morning today. So we will start with Christian Holzleitner, who's just sitting here from the DG Klima, European Union, and he will talk about what is being put in place by Europe, the certification framework for carbon removals and carbon farming. And then we'll have two interventions from US colleagues. The private schemes with Bruno Basso, and then the public schemes with Amy Swan from Colorado State University. Bruno is from Michigan State. And then we'll have two talks from Australia, one from Senani, who is, and Ben, who are both working at CSIRO. Senani will talk about the national policy in Australia, because Australia has put in place such a certification framework a long time ago already. And Ben will talk about the Pacific region context. And then last but not least, we will have Lisa explaining us how the EU soil mission can really help on working on those topics. And the discussion will be moderated by Jean-François Souzana, INRAE's Vice President for International Affairs, and Edouard Lancrier, maybe you can raise your hand, from In Vivo Agro Solutions. So let's go to the next slide, please. Just to let you know that, well, the Soil Mission plays a big role and has hosted the official launch of the International Research Consortium. You can see here who introduced it during the first Soil Mission Week last year in Madrid, with more than 370 participants in the room and more than 600 online. Next slide, please. What I want to really insist on is that that Soil Carbon International Research Consortium is something that is really co-created with a large community, with an international community. So you can see here on this slide how we want to go by August 2025 to a fully operational Soil Carbon International Research Consortium. But of course, it started with another EU project called CRCFF, which Jean-François Souzana led. We've had, along the development of the RC, a number of online meetings with international partners, and especially two large meetings in April, considering the monitoring, reporting, and verification framework that we are drafting together. Next slide. Just to show you that we have 5 regional nodes. Next slide, please. with our regional node ambassadors. So they're here in the room, so maybe you can raise your hand. So Tien, maybe you raise your hand. Wole, Beata, in the back of the room, but also Amy in the front row, and well, Senani and Ben, of course, for Australia. Okay, next slide, please. Just to show you briefly what we are doing at the moment. So we are putting in place the RC governance with a steering committee that met for the first time on the 13th of September, which is led by Jean-François Souzana as chair and Beat and Deborah Bossiou, sorry, from the Nature Conservancy as, well, they're both co-chairs with deputies, and Paul is one of the deputy. But we also have a scientific committee, which is shared with the 4 per mil initiative, an initiative that was launched during COP21, and which really works with us in good collaboration. Next slide, please. Just to show you the composition of the interim steering committee. So some of the members are sitting in the room, like, well, Jean-François, Paul, Deborah, as mentioned, but also Bruno, Christian, and people from different regions of the world. Next slide, please. And this is our scientific committee, which is shared with the 4 per mil scientific committee. So in order, to find synergies between organizations, what we did is really, well, decided to share that scientific committee with the one that was already existing in the 4 per mil. Can you go to the next slide, please? Okay, and just to let you know, yesterday we have an official collaboration agreement, and Paul signed it yesterday officially, waiting for an official signature by our president at INRAE. Next slide, please. So just to give you a flavor of what we're developing, we are developing 3 main services. So the topic of today, so an internationally harmonized monitoring, reporting, and verification framework. We already have developed one first deliverable on the topic, but we also developed a platform that is called Impact for Soil that was launched during the IUSS Centennial meeting in Florence last May. That was developed by our colleagues from CIRAD and also a Spanish company called Visuality. So the Impact platform is online. You can have a look at it. And we are also working on research alignment and calls, and we're working on enlarging a strategic research and innovation agenda. The colleagues are working on that, are in the room. We are implicated our regional nodes to develop it. And we're working also with the French research agency, the funding research in France, to work with other funding agencies around the world so that later on we can maybe launch a common cause. So just to let you know that you can join the Soil Carbon RC, and that we have at the moment 96 signatories from 44 countries with the map of where they come from. So I will now leave the floor to Christian, and please keep your questions for the discussion later on or for the coffee break. Thank you very much. Christian, the floor is yours.
Good morning. Very happy to be here and to update you on what we are doing in Europe at the moment. As always, on the next slide, I start with our big objective in climate policy, and this is to make Europe climate neutral by 2050. So this means we need to reduce our emissions significantly and rapidly, but we'll always have emissions in the system, not least due to the production of food and biomass. So for this, we also need to get much better in taking CO2 out of the atmosphere and then storing in our soils, in our forests, in the products that we make out of biomass, like, for example, bio-based wooden buildings. And then finally, we need to take a certain amount of that carbon and put it back where we've initially taken the fossil carbon, so like in the empty gas fields of the North Sea. So if you switch to the next slide, these new value chains that we need to see out of the bioeconomy, because we'll still need carbon. We'll need carbon for construction, for chemicals, for textiles, or to substitute all the fossil carbon. So we need much more sustainable value chains here, starting from how we grow the biomass and along how we use it, in particular also waste. Like food waste is also an important source of carbon that we then can use, for example, to produce chemicals. So for example, the inclusion of waste incinerations in the emission trading system with carbon capture and storage is an important one. And we will have a big communication from the Commission, probably by next February, on, okay, how do these new value chains look like? What is the clean industrial deal? So this means the demand of what we want from our land will not decrease, be it biomass, be it food. So to meet these demands by 2040, 2050, we really need a healthy and resilient agriculture and forestry. So this is why another big communication for the first 100 days of this Commission is a vision for a sustainable agriculture. And this will build on the recommendations of the strategic dialogue on agriculture. Like, and the first, and I think for everyone, the most important recommendation is a benchmarking system. We need to understand the data better, what is happening on our soils, in our forests. And here we are. And this is what we are doing. And so it will go right into one of the priorities of the next Commission. If we go to the next slide. So what we are doing with this carbon removal and carbon farming regulation, which will finally enter legally into force in December. And we have this framework where we want to accompany, so to say, the carbon as it goes, the biogenic carbon as it goes through the value chain. For carbon farming, we first still need to reduce the soil emissions, in particular from the drained peatlands. We have a separate category, separate methodology for that. Then we need to sequester more carbon in the soils, in the forest. Then we have the carbon storage in products. We look now at the methodology for buildings, for wooden buildings and biomaterials. We had a workshop on that last Monday, and we are getting an increasing interest on that one. And then we have the permanent carbon removals. So this is the geological storage, like in the North Sea. And they all come with different types of methodologies and certificates. So permanent removals have clearly the advantage that there, if you invest into this, you know the carbon is stored forever. With carbon farming, it's more about all the benefits that these practices have for biodiversity, resilience, and so on, really looking for these win-win solutions. And then, of course, you need to give the incentives that this practice is continued. So we give the incentive that our certificates are only value as long as you renew them. So, and then you also get into very permanent storage, but you need to check over time that the practice is always renewed. So how does the certification work? The framework itself sets out these quality criteria that you find in many other certification schemes as well: quantification, additionality, liability. And we put a specific focus on sustainability. This is something our legislators, our members at our parliament wanted. So every emission reduction, every carbon removal we certify is sustainable. So it also brings benefits for biodiversity, for soil quality. So this is really the focus. And you may also have heard the speech by our president on nature credits, where she really goes there. And this is also in the recommendation of the strategic dialogue. Markets should drive sustainability. So we need to create a good product that is easily understood by investors and that captures all these aspects. Not a tunnel vision on carbon, it's sustainable carbon. The currency is carbon, but we need to foster those practices that tick all the boxes. So what we are currently doing is we are working on the certification methodology. We'll have our next expert group meeting by the end of October. We come with a first draft on rewetting of peatlands, one on soil management plus agroforestry, and one probably on afforestation on degraded land. And then we are looking forward to all your feedback, how we can improve them and how can we make them really practical so that we have a larger take-up. The certification process itself, I'm still with, we want to welcome all existing private and public schemes to apply with us so that we can harmonize the European market there. The most important condition is that there's independent certification by third parties, like, for example, as you also have it under the Renewables Directive for the certification of sustainable biomass. We put a particular emphasis on group audits. We believe very much into that more farmers should get together to get into a landscape approach. So this is also something I'm very keen to discuss so that we there also have a good leverage and simplify for farmers to get together. And then we want to make a lot of information available. This is also key in our framework. So we will publish all audit reports. We will have a certificate of compliance, and this certificate of compliance should have all the information that's useful for the Scope 3 reporting in the value chain, that's useful for the national reporting, so for LULUCF. This is, I think, a major driver how we can move more to Tier 3 reporting under our LULUCF regulation. But it's not only like that the value chain should see this, but it's also that the member states and the public need to see this. We have such ambitious targets for our LULUCF regulation. We really need to get that in. And I think this data transparency will be important both for the public acceptance as well as it will simplify then a lot for the operators. Because if they can say, look, this is like an emission factor, that's a Tier 3, exactly fits to my plot of land, that will make it so easier. So this is also why we do the soil monitoring law, the forest monitoring law, to get this going. And then in addition to that, we have these certified units, which are then the credits that can be traded on a carbon market. And this is where I go on the next slide, because of course, this is the big question: what can you do with these certificates? And this is something we are working on. Of course, we want to help the voluntary market, which is not in such a good place for the moment. So we hope with our certification, but also with green claims, with the Green Claims Directive that says how in Europe climate neutrality claims can be made. We will create a more stable framework for that. Green Claims Directive still needs to go through the final round of negotiation in Parliament and Council, but we hope that we can finish that early 25, and that should help a lot. What we also want to do, we want to do some workshops in the first half of 25, where we see whether we can like mobilize kind of a public-private fund that could start buying these our credits. We see an interest like from the EIB, from national promotional banks, insurances like Munich Re, Swiss Re. In particular, insurances could be really the first buyers of that, because they could then really build up like a portfolio, a risk pool of these credits, and add a lot to the permanence of the credits in Europe. And we could really have a very efficient way of organizing a European voluntary market. But I think this will not be enough. We need to talk about compliance markets after 2030. On the one hand, on the ETS, on our emission trading system, but this will be for the permanent removals. So there we talk about bioenergy with CCS, direct air capture with CCS. But then we also have a project ongoing on, okay, how could market-based approaches look like for the agri-food value chain? Also, one of the outcomes of the strategic dialogue was that they are asking the Commission to look into this. We are doing this. We're looking into emission trading system, but we also look at other options. For example, mandatory sustainability standards for the food processors. So that could be also first and quick step to get the market going. A lot of food processors are already looking into this. I think they will be happy to have our CRCF, to have more harmonized conditions. And then if we work there a little bit further, we could create quite a stable, predictable demand for the sector, because I think this is necessary. Farmers need a perspective until 2050. Where is this going? And we will also, what I didn't mention before, work on methodologies for fertilizer emissions and livestock over the next year. So by 26, we should really have the whole farm. Then I have, I think, one final slide, very operationally, what we do on the implementation of the framework. As I said, we have the next expert group meeting, 21st to 23rd of October. We'll come out with some draft methodologies. Really looking forward to your comments. If we get enough positive replies, we are confident that we could go into proposing delegate acts on that, so to do the formal procedure that, by 25. We also have to do the implementing rules on the certification process and the registries. If really everything goes very well, we could start, or certification schemes could start in 26. And then by 28, we then also have this EU registry. So we would have a single marketplace for Europe on every type of our credits. And then, of course, one has to see how will the policy look after 2030. I would also hope that what we are doing here is really a very good first step into this benchmarking system that will be one of the key tasks for the next Commission. Okay, thanks a lot for your attention.
So we have a lot of food for thought for the discussion later on. So now I give the floor to Bruno. Bruno, thank you very much.
Good morning, everyone. It's a great pleasure to have the opportunity to share with you some of the aspect of carbon markets in the US. I will provide this overview of the carbon markets, but also trying to end with, I have to wear my scientific hat. I'm a professor at Michigan State, so really would like to bring potentials improvement that could lead to more transparent and more robust systems. So I'll present some of the advantages and disadvantages of different schemes. So you may have seen that map, and maybe you don't know, but the Midwest is actually even more photosynthetically active than the Amazon during the peak vegetation in the summer. So we are here just because we know that agriculture plays a critical role in carbon drawdowns. Basically, plants pull CO2 from the atmosphere for living. And what we still manage, unfortunately, the way land is managed to be basically almost the second sector, depending on different calculation, with a quarter of the emissions, associated to the agri-food systems, because there were, fertilizer and other components of the agri-food system. So briefly, I don't think you needed to know which company does what, and even though I'll touch upon, but you know that we have pretty well established, but not necessarily major trading, and I'll explain some of that. You got a voluntary carbon markets. we have a much stronger Scope 3 emission scheme. I have the pleasure to serve on different boards of large companies like PepsiCo on the sustainability components, and so helping them basically bring the science perspective. But what is happening, Scope 3 and practice adoption are really joining, and so many of these companies pay farmers to implement regenerative practices. So you all know that, but I just thought it was useful still to understand that the credit is a permit to emit, right? So you have the possibilities like having a bank account. So it's a tradable asset, similar to a certificate that represents that someone else could still emit someplace else. And so simple definition, offsets, by definition, buyers are outside the agricultural industry, and insets buyers are inside the agricultural industry with different regulations and different way of reporting, because most of the insets are really used at the moment for shareholders' return. So science-based target initiative, reporting and be able to say to the investors, what are you doing in terms of, carbon markets and biodiversity and all the other aspects. And so the important thing here is that the credits are created compared to a baseline, and we'll come back to this because we have pretty strong opinion on that, how that should work. From a scientific point of view, the policy may be different, but so just a simple overview to again separate, the offset buyers outside the agricultural industry, rigorous implementation of the robust system, basically certifying what is happening on the farm, independent auditing, Vera, Gold Standard, and CAR are the three main registry that they do that, the certification. The farmers basically decides to join a project for a particular length of time, 5, 10 years, and then basically is willing, he or she willing to complete all the enrollment forms and start uploading all the basically the management information, things that they show reduction on the emission in terms of practicing. I'm using enhanced nitrogen fertilizer, for example, or adopting cover crop and so on. The inset markets, again, within the industry, farmers provides the data because of the implementation of the practice. And the Ag Corporation, as I said, they can basically pay the farmers based on the practice adoption, the others based on the credit sold. So the in the US, you probably remember that in the 90s, Chicago had a stock exchange, based on carbon. Then unfortunately, where it was really ambitious back then, we didn't have the technology, anything close to what we have. And there wasn't as much sensibility to, sustainable food system. So it was really just beautiful to think about how much in advance people can think, but unfortunately, the economics didn't support it. So later, in the basically beginning of 2010 and so on, and for full disclosure, that word there, SIBO, which means food in Italian, it's a company that I co-founded with Vice President Al Gore, Flagship Pioneering, the owner of Moderna and PayPal, and a lot of big investors, and still in the system for 15 years and now for 10 years. And so just to be able, I'm still a professor at the university, so we're independent from this point of view, but I make sure they stay out of trouble. And there are many companies basically implementing different type of insets and offsets, and so long list and pretty aggressive in terms of commercials. And for example, Bayer has a really strong program, both globally, Indigo, Carbon Now, and Yara, and so on. So the farmers are really bombarded with different systems, but they see the benefit. They're starting understanding the value for one reason now, that in Europe is not, again, going in that direction, sustainable aviation fuel. So sustainable aviation fuel does not require the calculation of additionalities. So the problem about the rigorous system is that many farmers are already doing no tillage or cover crops. So as a result of this system, USDA, and I know Amy will mention some more of this, but launched this basically a $3 billion investment to accelerate practice adoption. So you have implementation of pilot projects that new farmers, basically implement no-till, cover crops. Digital agriculture is part of it, better nutrient management, premium based on, sustainable sourcing, and even some components of biodiversity. I'll talk a little bit more at that. We have different way of monitoring practice identification through obviously satellite and internal reporting, auditing. And one valuable thing is that the education stakeholder engagement and outreach is very strong in the US. So the farmers are really have the opportunity to improve their management and the complexity of the system. And eventually this is compliant. They can still sell the credits, even though money comes from practice adoption. And just to give you a general idea, in the US, the millions of acres to cover crops have increased from 10% to 18%. And no tillage is close to 39%. So these are numbers, being a European and knowing a little bit European agriculture, are quite a bit larger than what is happening in Europe, especially with tillage. I mean, it breaks my heart to see these small bore plow fields still happening, and that's equivalent to having carbon being lost, like the dollar sign, invisible. So that's a positive thing. Now, getting into the science, I wanted to show, I know the slides is overwhelming, but just bear with me. These are some of the best long-term sites of comparing right next to each other, tillage and no tillage for an extended period of time. So at the university, at ARS. And so I say, I don't want to really just, make conclusion about measurements, but are they really more certain, that as you'll see the differences from 1 year to the next in terms of sampling, 5 years, 10 years, the mass balance doesn't close. You have significant amount of gains or losses, which are obviously due to error in spatial variability, laboratory measurements, and a lot of other things. So we have to be careful in thinking that the volume of a small probe is representative of what is really happening on a large extent. So my vision on this is that the improvements with the, I know Amy will mention the IRA and how much, more detailed measurements in scientific context and representative of location should be. But if we think that we're going to have a really robust carbon measurement with measurements on the farms, that's a little delusional to my point. So this is an example of a study. This hasn't been published yet, but we sent 36 samples to different labs, and we came back, with none of them is really wrong. They just use different procedure. And I know Lucas has made the pledge going one lab, and they are about 3 years behind, providing. So there are this recent study from colleagues maybe at Colorado State University, depending on the sieving and the different labs, you have changes that go from 1% to 5% of the same exact sample. And one of the most, I spend time in the field still. And this is people do not pay attention about bulk density, measuring bulk density or adjusting bulk density. So I couldn't draw this any better than showing the rod that takes that measurement. When you go 5-10 years later and you have a reduction of bulk density because you put more air into the system, you will have basically the rods come short, and then you're not sampling the same. So you got to adjust. And luckily there is a simple, you download this correction. There's an Excel file that depending on how much bulk density has increased, this could be 33 centimeters rather than 30 centimeters when you started. So, but the problem, even in the field, the measurements are not done by people that really care. I've seen, soil fall off. And that's already, a large error, source of error. One of the ways that we thought in another paper that I've been working on spatial and temporal variability, capturing them. And so for every single field in the US, I developed this concept of yield stability, how stable production is. You know, there are areas that they're constantly underperforming, areas that they are always high yielding, and areas that they fluctuate from one year to the next. So we hypothesized this. What if we sample, you know, based on the yield stability? The hypothesis is that lower yields return a lower residues, lower carbon. So maybe we could confine measurements, much reduced number within these zones. And indeed, they worked between, you know, quite a bit, significant differences between carbon stored in the low unstable zones and high unstable zones. Then we did partitioning with Francesca on Cotrufo on different type, what type of carbon is present in the different ones. But this is a potential way of improving stratification. Use plants as indicators of what they really explore in the field, not just in 1 year, but over an historical length of time. So I'm going to go fast through the use of models. I've developed models with Joe Ritchie's SALUS system approach for land use sustainability. This is just an overview, an example. I really encourage to understand that if you want to do carbon farming, you have to capture the impact of tillages. You have to impact of, you know, different genetics. And so decomposition models are not ideal to do an ecosystem model. So ROT-C is a particularly very valid model, but it doesn't capture changes in the field in terms of genetics or, you know, tillage systems and so on. So you really have to capture the soil plant atmosphere management interaction to be able to do that. So that's a different, basically the differences of the measurements that I showed earlier from 5 years to the next. And if that was your last year that you were going to be paid on, to me, it's equivalent as a pharmacist is trying to weigh, you know, the medicine on a fruit vendor scale. I mean, the changes that they are so small, and the models do a better job in capturing carbon. We know it takes a long time to change, but you see there are 7 to 8 tons changes in very short time in these measurements. Okay, so just remember this. You gotta be careful in understanding that the rate of change, it's much smaller. It's like the nugget in geostatistics. You may be sampling at a scale that the variability is much smaller. So what are we doing with this? An important thing, I mentioned that dynamic baseline it's mandatory. I mean, it's like you can make really wrong assumption. If you think that you're going from a conventional tillage to a no-till, well, that field is no longer under conventional tillage or that area. So you just make assumption that that number that you sample on, you know, time 0 will stay versus, you know, conventional tillage, if the weather is good or whatever, you know, brings, that can be the red line. And so you may be paying a delta compared to a static baseline, which is not really realistic. So you have a type 1 error and you have for, you know, a false positive versus a false negative. Conventional tillage can continue to go down as an example versus, you know, the climate smart. And so that's really the benefits of how much you sequestering versus to the original baseline. And same thing here, you be penalizing when it is really not much of a change. So how do we get to that? We making this basically really big effort. Is supported also by the US government, the Office of the Chief Economist, and we're running multiple models together. So my lab has spent a significant amount of money and investment in programming and so on. So with one click, we run 8 models at the same time at a very high resolution. So basically 30-meter resolution. We aggregate, and so that's basically the models. The only 3 models in the US that they are certified by Vera are SALUS, DayCent, and the NDC, which is not here. But we also use sticks, and I have called postdocs that is in charge of running sticks. So basically, we're able, you can click on any of these areas and you have an understanding of the implementation of the no-till and cover crop versus the baseline. Now, this is the comparison of the models against the measurements of the long-term sites, and it makes, so does a good job. The trend is okay. Yes, the R-square don't pay attention to that because that's the slope of this curve is not on the one-to-one, but in general, models do a better job. By the way, this is completely uncalibrated. So we haven't tweaked the system to be able to reproduce the observation. So we feel really good that the ensemble, whether it's the median or the mean, really helps, because see the deviation, all the envelope around the color of the blue or the red. If you were to use model 1, it can be the bottom one. If you were to use model 10, it would be the opposite. So you would have the ensemble really captures, these models all have merit to be, used. They've been around for over 20 and more years. And so we feel that this approach, because it's available already, I mean, through an API, my goal is to make it available on a global scale. We move into Argentina and Brazil to having pilot projects both with organization like APRESEEDS and INTA and CONICET and so on. So that's one of the approach that I really wanted to underline. And so the question is, a farmer can say, I have baseline, I'm a conventional tillage, I want to go to no-till. So the implementation through a multi-model ensemble, that's the benefit of getting the impact of no-tillage. Then you have another farmers that would say, I have a rotation that includes potatoes, and I always have to have, tillage system, but I'm interested in growing cover crops. And so you will have the separation and see the impact due just to cover crop. Or if you're already doing no tillage, but not cover crop, you see how that changes spatially. And so you can click on any of these numbers, and these numbers are basically really repeating over the literature. On average, no-till and cover crop sequester about 300 kgs. You can't go much farther than that. So it's basically 1.5 or so CO2 equivalent. And the measurements will not be able to give you those answers as well. So trust a little bit more the systems and the models, and be a little bit more dubious about the way measurements are done. One final slide is, what is really important that we learned is soil texture and initial conditions drive the system. So you can see this is conventional tillage, and you still sequester carbon in conventional tillage if you pretty much to the bone, very little carbon to start with. Then you have 30 to 60 basically stocks. You still now, as you go to larger amount of stocks, like some of the states where they have really Illinois and so on, you cannot continue to do tillage because you got to do the opposite. You got to do no tillage and cover crops to maintain the level of carbon that you have when you really have high stocks. So this has been submitted. Hopefully you'll hear about it, and hopefully you'll see the API soon. So this is basically, you can cut a tile and you run what I showed, the dynamic baseline. You have the regenerative, and it will still vary spatially. You do the differences in delta map, and those are the numbers that basically will help you understand the benefits of a practice for that particular area, which are still spatially variable. And so on average, we can get 0.1 gigatons of CO2 per year going from no tillage and cover crop compared to just simple no tillage. So conclusion, we can't wait. That's the thing. I mean, the perfect system, good is the enemy of excellent. I mean, it's just excellence, the enemy of good. We just can't wait. We just, there is this saying, it's maybe extreme, but waiting is equivalent to denial. I mean, you just have to move faster and push practice adoption. So when I'm in the US, I always brag about how much ahead Europe is in regulation and doing but then US is doing an incredible job in practice adoption. I mean, they're moving much, much faster than Europe. The system, the university are just very, embracing the concept of, and the companies, obviously, there's so much money in the US invested in the agri-food system that all we have to do, raise a hand, and we get quite a bit of dollars. So we can't measure everywhere. You need modeling. Models can be over-calibrated, and if you over-calibrate one model in one side versus another side, we're not helping each other. We increase more chaos, and that's what is happening. So hopefully we will have a standardization, which I'm trying to propose through a multi-model ensemble, where you basically don't need to know what the numbers of the models are, 1 versus 10. This is running the most reliable model from a system that basically gives you that particular outcome. They are spatially calibrated on stability zones. model needs to be tested by independent data set of good quality, which is obviously not necessarily just really available. Models need to, not just carbon, you have to match the system. You gotta have yield and soil water and soil carbon in the very detailed measurements that university and other system could have as benchmarking. Model need to capture the spatial variability. And as I've shown, plants are the best indicators of what they see over time, what they have seen over time. Having spatial variation of soil maps where the plants do not reflect that soil map, it is really not necessarily useful. Multi-model ensemble provides an opportunity to benchmark models, develop a dynamic baseline, reduce uncertainties, as we show in the paper, significant amount of reduction in the uncertainties, and continue to develop better models. It's actually surprising that you can only understand how good of a model is when you start benchmarking them and comparing against them. And the apotheosis is actually running them really together to be able that some of the improvements may come from different features from different models that they are capturing into this multimodal ensemble. With that, I thank you very much for the opportunity and the attention. Thank you very much indeed.
Thank you very much, Bruno. I leave the floor to Amy right away.
Hello, everyone. Amy Swan from Colorado State University. Is this? Oh, over here. Okay, there we go. Okay. So I'm going to talk about some federal and state policies in the US. We're going to focus on, at the federal level, some MMRV investment and work on quantification, and then implementation of climate smart practices. So, oops, wrong way. Bruno briefly mentioned this, but in the Inflation Reduction Act of 2022, this is like one of these huge congressional spending bills that was passed in 2022. Within that, there was $300 million set aside for investment in MMRV over 8 years through the US Department of Agriculture. There are two main focus areas of this spending. One is data collection and data management, and the other is around models and tools. So, whoops, sorry, wrong way. So over on the data collection side, this is kind of a huge thing for us to have soil carbon monitoring in this national network that is done in a very rigorous fashion, as Bruno was indicating in his talk. We actually had a start on a soil monitoring network in 2000, when did that start? 2006 or 5, something like that. And then the funding got cut in 2008 in the during the financial crisis. So this was a huge blow for us because it took a long time to get off the ground, and then it got cut, and then it sat for all this time. Now we're getting back into it. There's also a greenhouse gas research network, and this is focused on nitrous oxide and methane, and that is in both in fields, in wetland rice, and in livestock systems. And then there's improvement around conservation practice standards and implementation. So within the US, we have been incentivizing farmers for decades through the Natural Resources Conservation Service, which is under USDA. But of course, a lot of that was around managing other resource concerns like erosion and water management and habitat and things like that. So this is an improvement that's really focused on how we can use these same practice standards to improve greenhouse gas mitigation. And then also just keeping track of all this data. So NRCS does all of this incentivizing around adopting practices, but we actually don't have that great of data on where those practices are adopted and in what manner and that kind of thing. So just managing that data better. And then all of this can feed into better models and tools. And then we also want to be able to report these improvements in our national greenhouse gas inventory. Let's see here. And then, oops, too far. Okay, not too far. Hold on, sorry, everybody. One more. Okay, so Bruno mentioned this. This is a huge funding opportunity that came out in 2022 from USDA. So they funded $3 billion and 141 projects around development of climate smart commodities. So this is basically to support the production and marketing of these climate smart commodities, and these projects are up to 5 years. There's a few major goals. The first one is to provide financial and technical assistance to growers to implement these practices, and then to pilot innovative and cost-effective methods for quantification and monitoring and measurement. So there's actually like a pretty big component around improving quantification within these projects. And then also just developing markets and promoting products. So I'm not going to go into some of the, I think we kind of were complementary here. I'm not going into the details of how these projects work, but just some of the, some of the stats. So there was actually a particular focus in this program to expand outside of some of the more common commodity crops. So really focusing on some innovative crops, some novel crops that maybe have a lot of potential. It also has a focus on livestock, so this isn't just croplands. And one of the other notable things is that you'll see down here on the right, most projects are under $5 million, but there are actually some that range up to, I think that says 90 million. So some of these projects are quite large. The other thing to know about these projects is that they do involve universities. I think they had to be university led maybe, but they also involve a lot of private companies. And then also things like the Corn Growers Association, a lot of nonprofits. So the groups that are involved in these projects, it's not just university research, it's a lot of private involvement and also private investment. So let's see, the other stats, we also include a lot of tribal groups as well. And it's estimated to reach 60,000 farms and hopefully around 60 million metric tons of CO2 equivalent sequestered. And then the last, well, okay, actually, no, I have two more things I think on this next slide. So this is a new initiative under USDA to provide more technical assistance to growers on getting involved in voluntary carbon markets. So like Bruno kind of put the slide up with all the different markets and things going on, and just providing a little bit more guidance to farmers so that they can participate in these markets and also negotiate fair contracts and kind of know what they're getting into. I think I actually skipped over a slide. The other thing I just wanted to mention around quantification, if you go backwards, I'll just mention it. We don't have to show the slide. I also had a slide around USDA was also mandated with developing guidelines for greenhouse gas accounting for farms, ranches, forestry operations. And they had produced that first set of guidelines in 2014. We're going the wrong direction, but that's okay. I'll get to this in a second. Sorry, it was backwards. I think it was actually before the Climate Smart because I messed up my clicking. There we go. Here it is. Yep. So this is a methods guidance that USDA developed in 2014, and then they just released an update to this guidance in 2024. So this is really, if you're familiar with the Comet Farm tool that our team develops, this is the backbone of the quantification behind that tool. And this includes soils, but it also includes livestock emissions and forestry, agroforestry, basically all of the sources. And this is meant to be, this was a group of scientists that USDA brought together to develop these guidelines. And this is really a living, changing guidance that they will continue to update as new methods become available and new science comes out. So we can go to the state section now. So I just wanted to show a little bit about the states because, as you probably know, the United States is a very large and diverse country, and our states are quite large and have a lot of their own things going on. So this is just a quick highlight on this group of states that got together in 2017 and call themselves the U.S. Climate Alliance. I don't know if you know anything about what happened in 2017, but let's just say politics were changing in the US. And so a number of states decided they wanted to pursue a lot of the aims of the Paris Agreement as a coalition. So that's one of the activities. They don't focus just on working lands and agriculture, but that's one of their missions. And then I think more importantly, actually, is there's been a lot of activity in the US on initiating soil health programs. And so this is a map that I got from Nerds for Earth. This is kind of group that's been tracking soil health programs across the United States. And the green states are states that have passed some type of program around soil health. So there's some variability in what these mean. Sometimes they've initiated a whole new program within their government. Sometimes it's just underneath their Department of Agriculture, whatever that is. So as you can see, there's actually quite large uptake. The green ones are where they've already passed. The blue ones are where there's a program pending. And then even in these other states, there's some kind of activity that's going on around developing a soil health program. And while, of course, when we talk about soil health, these aren't necessarily explicitly focused on carbon sequestration and greenhouse gas emissions, but of course we know that that is one of the major benefits. So I was just going to quickly highlight one specific soil health program. You can click on the thing, and this is in California. I think the statistic is that if California was its own nation, it would have the 5th largest economy in the world. And it's a very important agricultural state, especially for what we call specialty crops, so vegetables, fruits, nuts, things like that. So they have a cap and trade program in California. That was one of the things on Bruno's slide of activities in the US. And within that, proceeds from that cap and trade program go into this greenhouse gas reduction fund. And then that greenhouse gas reduction fund can fund climate investments. So these are sort of the unregulated, maybe you can click for me just once, sectors that they want to encourage investment in, but they have to have a greenhouse gas benefit of some kind. And so that's things like transportation and clean energy. And then within that are natural resources. So some of that funding was used to fund their state soil health program. So this launched in 2016. It provides basically practice-based incentive payments to farmers and ranchers. And then it also created a number of on-farm demonstration sites that include a lot of measurement as well. Over the course of the program, they've distributed $167 million, and that includes almost 1,500 incentive projects and 70 demonstration projects, and they estimate that at around 1 million metric tons of CO2 sequestered. So I think that's all I have. Yeah, thanks.
Thank you very much, Amy. And now we move to Australia with Senani.
Thanks, Susan. So I'm going to briefly talk about monitoring soil organic carbon stock changes in Australian agricultural systems, specifically on science-driven national scale policy formulation. So let me first acknowledge the traditional owners where we work in Australia, and pay my respect for their elders present and past and present. And I also like to acknowledge a lot of my colleagues within CSRO and externally, including some of the past colleagues who the work been built up, which I'm presenting today. Oh. You can skip that slide. So just to give a quick introduction, so there's a new policy came up in 2022, something called Climate Change Bill, which aims to reduce the emissions by 43% 2005 level by 2030, and then net zero by 2050. It's a very ambitious target, but that's a target that Australian government currently working based on the Paris Agreement. And when you look at soil carbon, soil carbon is a so the CSRO has done a report. It's been identified soil carbon as one solution. It's a mixture of the other solutions as well. If you look at the commercial readiness in your y-axis and the cost per sequestering 1 ton of CO2, you can see that soil carbon sits somewhere here. So there's a huge potential for soil carbon. Australia being a large mass of land, so there's opportunities to sequester carbon, not everywhere, certain parts of the country. So just before I move to the policies, I just thought of give you a very high level overview of the past and current CSR research on soil carbon. So this research been developed over the last 2 decades based on different aspects. One is on the quantification of form of carbon. CSR spent a lot of time and effort developing new methodologies, not only total carbon, but beyond total carbon, quantifying different forms of carbon. So we have our own fractionation scheme, which we call POC, HOC, and ROC, slightly different to US one or even to some Europe. So we call particulate organic carbon, humus organic carbon, and resistant organic carbon. Resistant organic carbon plays an important role in Australian landscape because fire is an integral part of the landscape for thousands of years. And they have different turnover times. And I'll show how these carbon fractions are used in different modeling perspective in some of the other slides. We also use a lot of sensor-based estimation, not only for the total carbon, but also the estimation of the bulk density. As Bruno mentioned, bulk density plays very important in quantification of stocks, and small errors in bulk density can lead to a significant stock changes. So there's been a lot of development in the infrared space, both mid-infrared and near-infrared. We've been developed national libraries, which is consistently can measure both total carbon and carbon fractions using the infrared libraries. And these libraries are evolving, they're not static. We always develop those and update those models. And we're also working on different sensor-based technologies to estimate bulk density, especially the gamma. We're also developing tools that you can identify the de-risk the carbon farming decisions, where you can identify the bucket sizes where you can further increase the carbon, especially considering more stable forms of carbon, mineral associated carbon. Next slide. Additionally, we've been also developing next generation models. We also believe that models will play an important role. We use both data-driven, process-based, as well as hybrid modeling. There's a more interest more recently on hybrid or surrogate modeling. So we try to combine all these aspects, very similar to Bruno's, to come up with a more ensemble modeling approaches. Next slide, please. All right, with that science background, when you look at the policies that's related to the soil carbon in Australia, especially for the carbon farming projects, it actually goes back to quite long, almost like 14 years back. So there's an act was legislated in 2011. It's called Carbon Credit or Carbon Farming Initiative. That's the key methodology, the determination or the act was related to all the carbon farming activities in Australia. So the first soil carbon method, which is Australian government developed with the scientists and other academics, is in 2014. So that method is no longer available. And then in 2015, the new method was developed, which is based on the modeling. So there's only few management practices were considered, and it was a default method where you have a large scale areas. You have if you adapt a one management practice, then you get some known carbon sequestration rates. And the 2018 is a very important here. So the 2018 methodology was the one that was introduced measurement only, which is based on a design-based statistical principles. I'll go with some examples later. And then 2021 methodology is a new improvement to 2018 methodology, which is also based on measurement and measure model. So which give provision to use models, but along with the measurements. So which is a high improvement of the methodologies. And after this 2021 methodology, there's been rapid uptake of carbon farming, soil carbon farming activities in Australia. Next slide, please. So rest of my presentation is mainly focused on giving everyone a very high level overview of the 2021 methodology, which is for the project level application. and then also how Australia is reporting at a national scale for the LULUCF, for the IPCC, UNFCCC reporting. All right, I just try to summarize the different methodologies that we use in this table. We have at a farm scale, we have carbon farming project. At a national scale, we have two different types of modeling approaches. So in farm scale, so carbon farming project, this is the Australian government 2021 methodology. So it's a measurement and measure model. The one of the distinguished thing is that the method itself does not define what type of model. It can be anything. So it's model agnostic. And it's a direct or a tier 3 model, whatever the model that we're using. And the depth support is 0 to X. So X can be any depth up to, but the requirement is that you need to have 0 to 30 minimum depth so that it can be reported within the national inventory, the carbon credits. That's all right. So while it's coming back, so the 2021 approach developed by the government, it's a voluntary carbon credit scheme. Yes, I can see a slide here. Yeah, I can see. Yeah, can I speak? Yeah. So the 2021 methodology is a voluntary scheme, which is like, individual farmers can adapt or register for these projects. And when these projects are registered, there are methodology, and then the projects are actually managed by a government organization called Clean Energy Regulator. It's an independent organization. And the methods are developed by another government organization. It's a co-development method, so similar to the European Union. So the government plus the industry plus the academia researchers involved and develop the methods and then pass through the parliament. But the management of the scheme is done through authority. So when the credits are issued as Australian carbon credit units, ACCUs. So we call them ACCUs. And then ACCUs are issued for each ton of carbon stored or avoided in the landscape through the management-induced practices. And these ACCUs can be tradable. These credits can be traded to the Australian government or state government or private sector. So if you sell it outside Australia, obviously those credits cannot be reported in the national inventory. Okay, next slide. So in the 2021 methodology, there are, as I said, there are two sections, Schedule 1 and Schedule 2. One of the important thing is this methodology, which is actually based on design-based statistics. So that's the science behind the methodology. So which means that we estimate unbiased estimates of the mean as well as the variance over the time, which is used to calculation the stock changes. So there are two sections of this methodology. So one is called Schedule 1, another one is called Schedule 2. Schedule 1 is based on the measurements. So the measurements can be either you go to field and use the traditional methods to measure soil carbon stock calculations, or you can use sensor-based methods. So that's the difference between the other methodologies. Additionally, the Schedule 2 is a hybrid approach where you can use measurement as model. So if you are you can move between two schedules, but if you are using Schedule 2 of this determination, then you have to have certain areas of the area being sampled and then validated.
Sorry, I don't know if you have time for a question, but how do you draw a baseline in Schedule 1? Do you draw the baseline?
So the baselines are actually need to be measured. Whether you are using a Schedule 1 or Schedule 2, you still need to go and field measure. So one thing that is also difference that Bruno mentioned is that the baselines in this methodology is static. They are not dynamic. Okay. But you have to measure it. Whether you are using models or a measurement Schedule 1 or 2, still need to measure baseline.
Okay. So you take the
Yes. So to give a little bit of more detail about the science, so it's based on design-based principles. That means based on the probabilistic sampling. So you get unbiased estimates. So the methodology itself suggests that you need to have something called carbon estimation area. So the carbon estimation area has a unique land management practice that's been approved by the legislation. So you can apply that management practice to that area. And then the land need to be stratified, very similar to Bruno's presentation, where he classified based on the long-term NDVI data. There are requirements that how you can do this stratification based on the NDVI data. Whatever the covariates that's relevant to the carbon. So there's some guidelines say that you need to use these type of environmental covariates that's relevant to the carbon inputs to the system. So the minimum requirement is you need to stratify the land into 3 strata, and within stratum to collect 3 random sampling. Now, in practice, if you collect 3 strata and 3 random sampling, you get high variance. So in practice, there are more samples being collected to reduce the variance. Next slide. So once you collect the samples, you aggregate the samples into carbon estimation area. Now we use like a probability of exceedance. So if the total carbon for that particular area, for example, is 500 tons, megagrams of carbon for carbon estimation area, you don't get that 500 tons. You will be penalized for the variance and you get less. So that's why we have it's a method is conservative. So it's not, you don't get in all the carbon credits you claim, you will apply some discounts. Click. So this is the stock calculation in the methodology. In summary, what's important is that you do have the change in carbon, and then you have a component here which is calculate the uncertainties for the spatial variability, and then you have other discounts applied on top of that. So which is including the temporary discount for 25% for reporting first time period, and then you have permanent discounts. So these projects, most of them are registered for 25 years. Then you have more discounts if it's registered for 100 years. Obviously, there's no discounts long term. And then risk of reversal buffer. We know that carbon will change. Some years will go up, some years will go down. So there's a risk of overcrediting. So because of that, to avoid the overcrediting, there's another discount applied on top of those other discounts. Next slide, please. All right, that's probably about very general overview about the Australian carbon farming methodology. Then I'll very briefly will discuss about the national scale greenhouse gas modeling work. So we use a framework called FullCAM. So FullCAM stands for Full Carbon Accounting Methodology. So underpinning for the soil carbon is based on the ROTC model, but we do have like a plant growth models and other things connected to the ROTC. So that's why we call it as FullCAM, Full Carbon Accounting Methodology is a framework. So one of the key things we've done over the last probably decade is to how we can initialize these models in a landscape scale. We've been utilizing these measurable carbon fractions and replace the conceptual pools of the model. So you can run these models in a landscape scale. And then also we calibrate these models to this measurable fraction instead of total carbon. Next slide. So when you run these models, we have inputs coming from a different spatial resolution. We're working to improve that to come up with a consistent resolution and then consistent time frames. So another improvements we've made over the last decade is that use of digital soil maps as the initialization of these models. So rather than having a polygon-based initialization, we try to use a pixel-based estimate. So we can run, for example, these models are run at a 90-meter resolution or 25-meter resolution, whatever the defined resolution based on the inputs. And then we combine all these data sets and then we run the simulations. When you run the simulations, we consider these aspects, how to initialize the models. National scale, we initialize the model using measurable carbon fractions, which is improvements done through the CSRO research. We also calibrate it to the Australian conditions. We know that the Rotherham State is developed for in UK, and we have to calibrate it to the local conditions, which is a dry continent. And also the carbon inputs. Very important aspect for driving carbon models is derived from a water balance model with a simple water balance model. And also land management data sets. That's a thing that we are currently working to see whether we can get Earth observation data sets to improve it. But currently it's based on census data sets. All right, finally, more recently, we use this IPCC Tier 2 steady state model, which is actually developed through some of the work by Colorado State University, Stephen Ogle and his team. So what we've done is like we tested this methodology framework for the Australian context. Instead of, we initially used the default approach, but it didn't work for the Australian context. So what we've done is like, we also look at, again, whether we can replace this conceptual pools, active, passive, and slow in the descent model with our measurable fractions, just manipulating it. And we can show some results of that. So this is a comparison for like around 4,000 locations across the country. As you can see that the variability of the stock change is IPCC is quite high. It's not calibrated, it's just replacing the conceptual pools. But in general, the estimates are it's within that range of the Tier 3 model, which is really good. And then we also did the Boltzmann plot where you can see the difference, and then 95%, around 94% of the things are within 95% confidence interval. So final take-home messages. I think it's very important to use develop these methodologies based on science, and they are evolving. So for example, Australian methodologies are every 3-4 years, they relook at it. And one of the discussions we're currently having is like, rather than having soil carbon itself, can we do method stacking? There's a method developing currently called integrated farm method, where you try to stack different methods. So it's more sensible to have rather than soil with other elements as well. And selecting the appropriate measurement or modeling, it's depending on scale and depending on your inputs. So it's very important to consider that whether we have the correct inputs or at the correct scale. And one important thing is like quantification of the uncertainties. And if you know the uncertainties, that will be used to actually can be used as a discounting approach as well. That's it. Thank you very much.
Not bad.
Thank you. Yes. We'll move to the next slide. Thank you, everyone. So I'm going to take you somewhere completely different. We're going from high-end agriculture with significant investment in single countries to low input agriculture in multiple countries. Can you give me another slide? Thank you. Forward. Across the Pacific. Before I begin, much like Sanani, I'd like to acknowledge the traditional owners of the landscapes I'm talking about today, the elders past and present. They have a significant knowledge base. They've been here for a long time. And I'm particularly honored to be here to talk about their landscapes to you today. For those who don't know, this is Kiribati in the middle of the Pacific. It's halfway to Hawaii from Australia. This is the island of Taveuni in Fiji. This is the Pacific. This is what I'm going to be talking about today. 21 countries sitting in here of various types. I'm going to give you the context. I'll give you a tour through the Pacific. Things we should think about. We have low investment. I'll show you that we need to build our capacity here. We need to build our knowledge base, our measurement base, our information base before we can get to MRV. So this is a story about building those pillars. For those who don't know the Pacific and don't know what atolls are, this is Tuvalu. This is the soils of Tuvalu. As you can see, by definition, this is not a soil. This is coral, but this is what people grow food in, and it is productive. Seabirds transport nutrients here. We have organics, you can grow food. We're about 1/2 meter above sea level when we're standing on this location. If we move to some of the volcanic islands in the Pacific, and there's 3 classes of islands: atolls, volcanic islands, and raised atolls. And we come to the nation of Samoa. We have beautiful soils. They're very rich, very young, being developed for agriculture. As we talked about this morning, tillage is really a critical factor here. You could call this almost max tillage. Lots of tillage occurs to manage the fallow system. If we go to the Kingdom of Tonga, this is a raised atoll. So instead of being formed from lava and it's weathering, this is a coral atoll which has been raised up and then covered with ash. Very productive, just another different environment. As you can see, we went from different islands, and the key thing here is we're in smallholder agricultural systems. So less than 1 hectare, quite commonly. We got customary land, land under lease. All impacts on how we can measure and monitor. Can't bear soils talk without some soils. So these are young landscapes. So you might think, oh, they're a small island nation, there's no variation between the soils. This is just in the Kingdom of Tonga. As you can see, there's significant variation in these soils, differences in soil carbon content. You can get up to 10 or 15% carbon down in these wetland soils and 8 to 10% in some of the dryland soils. In Tongatapu, we're talking about a function of location and height. Above sea level is about how the variation works. Atolls is all about height above sea level. You've got 0.5 meter to 1 meter freeboard, and that drives the production. And the volcanic islands, much like work which has been done in Hawaii, is all about the age of the lava system and how much weathering has happened. Now, what's the issue we have here? Intensive agriculture is a fairly new thing here. And much like elsewhere in the world, when we have disturbance, we change the system. In these nations, we've changed the system from long fallows to short fallows, and we're losing carbon. That's a driver essentially of economics. But how do we manage this? If we zoom into Vanuatu, and I was there a few weeks ago, we have systems where we have mixed cropping. We've got four different types of sweet potato. We have coconuts, there's maize in there. Work by the CRCF is showing that those sort of systems are very stable. They're very fertile, carbon sits there. Traditional knowledge is there. Economics is driving us to this situation. Monocropping. There's still like mixed cropping in here, but it's essentially monocropping. We advise our growers to do that. We're driving them this way. So when we think about soil carbon in these landscapes, how do we evolve the system so that it's economically viable, maintaining carbon, and can we continue in low input systems? So there's no fertilizer coming in here. This is all just being driven naturally. Tillage is critical. They use this. We don't use pesticides or herbicides here, so they manage the fallow and with tillage. So how do you do that without killing the carbon? And so when we think MRV in these systems, it's not about measuring stock for trade. It's about measuring stock for nutrient management and farm productivity. It's just a different nuance on MRV, but it's the same thing. Now, as I said, this is a low input system with low investment, but through the Pacific Soil Partnership, there's a cohort of people across the 21 nations who get together to make this, to share information. At the Regional Pacific Heads of Agriculture meeting, it was endorsed that the Pacific Soil Partnership would develop a regional soil framework and drive the knowledge base here. It was identified that soil information was limiting, soil knowledge was limiting, our capacity and capability to measure soil carbon was limited. But through here, and the collective of countries have identified those things and put a priority to fix them. And we want this soil framework to deal with wine health, food security, and sustainability. So what's the policy setting looking like in terms of delivering this? So soil information. A lot of the soil information was in books, on shelves, and not being used. So it's been digitized and transformed into an online system so people can get data. These gentlemen here are reinvigorating PINGRIS, which is a one nation soil information system for PNG. versus the other system, which is for the whole of the Pacific. And this is a federated system developed by Manaki Whenua in New Zealand with our input as well, which has probably saved about $35 million of soil information, which has some baseline carbon measurements, so we can go back and use them now. Very critical after the eruption in the Kingdom of Tonga, because we could go back and get data and do assessments of the impact of the eruption. What we want to do is provide new soil maps for these nations to look at capability, capacity, and drive policy for carbon sequestration. Soil field measurement. So we talked about field measurement and doing it properly. We're trying to build capacity here to do this. How to sample for soil, how to measure carbon properly, so to enable proper carbon measurement, and also how to get the data back into the system. People don't have the skills, but they do know Excel, they do basic stuff. So how do we get the information from here to a database? And that's simple things, but really important. Building lab capacity. I can't stress enough that significant investment is needed in countries around the Pacific and others around the world for analytical capacity and staff support. There's no MRV if we can't baseline and measure soil carbon. You can't get primary productivity of plants to go without understanding nutrient management. It's critical. There's been training and workshops, such as through the Australian Soil Science Society, through agencies in New Zealand, to build capacity in labs. Measurement is still an issue, and getting robust measurement systems set up is critical. So one of the things we've been doing is using near-infrared spectroscopy and mid-infrared spectroscopy to actually reduce the cost of analysis for the countries. And it's quite successful. We're setting up libraries to measure organic carbon using MIR. This pulls the cost from about 50 bucks a sample, 50 Australian dollars per sample, to less than $3. We can set it up in a non-air conditioning laboratory and it can be used. We're looking at field NIR as well. So you can actually take the unit to the field. It's a bit bigger than your mobile phone. Measure in the field carbon, and then you can talk to the growers. This is your value. Thank you. So you're telling me to speed up. So managing the system, what tools and technologies can we use in terms of improving carbon, and what do they actually do so we don't need to go and measure? So the impact for soil has some data looking at change in practice, but if you look under the dashboard, there's not much for these specific type of soil. So high organic carbon soils, what do we do when we change these systems? Now, without a doubt, residue management, cover cropping is going to change it, but by how much, we're not sure. Whoops. So the future, and just to reiterate, it's two different things. Okay, that's the final slide. There's a slide here which is different. Oh, there we go. So in the future, investments required to improve soil carbon measurement. Without it, we won't get an MRV in these countries. Whether it's NIR, MIR, it doesn't matter. We just need to do it. Monitoring and reporting and verification is also required, but not just for stock. It's for driving food security and agricultural production. In these countries, disasters are a critical issue. So in Vanuatu, they expect to be hit by a Category 5 cyclone every season. So resilient soils is what is needed. And an MRV will help understand function. And I'll leave it there. And I'd just like to acknowledge Sanani, myself, and Rohit. Rohit's from the Secretary of the Pacific Community. He's the regional soil coordinator for the Pacific, and he does a lot of this work in his day-to-day job. So thank you.
We go back to Europe with Lisa, who's a member of the Soil Mission Board.
So thank you very much for kind invitation. Yes, I'm Lisa Pietola from Finland. I'm an expert member of Soil Mission Board and also working for the Finnish Innovation Fund, Sitra. And it's a future fund for, let's say, so that it's working for well-being within planetary boundaries. And this is about what we have today also discussed. So I'm very pleased to present this healthy soils aspect. As soil scientist, also it's really important aspect, and we have heard so much again today. But I will add. Great. Yeah. Okay, we have heard already a lot, but I will now move a little bit more on soil health issues, because soil mission is about soil health, how we can get our European soils healthy again. And why it is so? It is because soil support the ecosystem services, like we know that this cycling carbon and storing it and supporting climate adaptation, and also mitigation. And because our soils they are threatened in Europe, we really need to try to find a way how we can fix the problem. And the soil mission kind of tried to look indicators, the best management practices by 2030, and then when we know which is good practices and how we can show we can lead land managers towards more healthy soils, then we can have our soils healthy by 2050, let's say so. So this is kind of the program. And of course, there are other ecosystem services, and all is in connection. I see that I jumped one slide, so let's go back to this. So about this kind of program, which is funding program framework and the Horizon Europe, and it covers the EU countries, and this is also very critical because we have so different climatic conditions from north, from Finland, where I am, to south. So it is really we need to find the proper indicators to show the progress for farmers, for policy, and there we need scientists a lot and new programs and so. So and this mission is kind of a testing approach. So we really work with land managers, scientists, and also communities together at local level. This is kind of the key issue. And we work for agriculture, forestry, and also urban and industrial soils. So we cover all sorts of types. And the budget, it was this year was same than last year, so it has been increasing a little bit. Okay, now I go. That's this, and then I go over here. So the main goals that is that we establish 150 labs, testing sites to show the progress, to find the best indicators to lead the transition towards the healthy soils. And there is 8 specific objectives. Of course, we need to reduce desertification, stop soil seeding, prevent erosion, and reduce the EU global footprint. But this number 2, conserve and increase soil organic carbon stocks. This is the topic of today. But it is linked to this number 1 and number 3, and also this number 6, which is improved soil structure and biodiversity. Of course, when our soils are functioning good, then we can conserve and increase soil carbon stocks, as we have said and seen today. So they are linked. They have linkages. But the thing is that the water is missing here. But we need to see also that the water management, it is also a very important part of the well-functioning soils, and so we see that kind of integrated in these objectives. So today we are talking about carbon stocks, carbon farming. So I picked 2 projects which are dealing mostly with that. So this credible network on carbon farming, we try to find the trust for that. So then we really restore carbon and sequestrate carbon, so we can show it and we find the trust And then the second is this monitoring and reporting and verification of soil carbon and greenhouse gas balance. So we have not yet talked a lot about greenhouse gas balance, but we should talk. And so it's about removal and emissions, and agricultural land and soils. They are doing both because we have this photosynthesis and also this soil emissions. So both sides should be. So, and that makes that difference between fossil emissions and biogenic carbon cycles. So this Marvic and Credible, these are really important projects ongoing now within EU submission. And also I'd like to look this benchmark, because this is really trying to find the best indicators. So all are needed. And some words about Credible, so that how we can build these farming markets and policies so that we can really trust them. So the importance is that there is effect evidence and integrity of carbon farming. We have talked about that today. And for me, as a farmer also, so that agricultural management must be proven and validated. We need to recognize that. And then this nature of biogenic carbon, it should be understood better than it is today in our country. And of course, different regions across Europe, we have been different places in the world, but also across Europe, there are a lot of variation. So this is tough work, but we need to do that. And then it's not. So let's stop for a while for this picture, because this is really important if you think about today's agenda. So this plant see input in the soil here, how we can really do that, so that all can trust the data. And also there is this propagation, catch crops, no-tillage. Of course, we need first data sources, climate soil, climate and pedoclimatical conditions, and then this land cover, how much it is covered by green plants. But then also this, we have data sources and then farm data. We need to do the job where the carbon is really removing. Okay. And then the test sites need to be very well known, so we need these benchmark sites. So all this is kind of a combination of different projects, and there are pathways how we can end up these rock soil models. And we already, like Bruno said about this plant and the soil continuum. This is really important to see the above and below ground atmosphere. So we don't have yet data. I just phoned to Lisa Kurmala, who is in the Finnish Meteorological Institute, taking care of the one bird package, and they are providing data very soon, but not yet on cover crops. So I was hoping to show you something, but you see that it's the ongoing project, and we are going to have the data soon. But I found some data from Finland. So if we look at sample data of cover crop, it's ryegrass with barley. So we can, by sampling, we can count that there are spots for over 2 kilos per dry matter per hectare, but a lot of variation, a lot. And of course, we cannot just sample, but so we need also the satellite measurements for validation indices, which Marvic are producing. But anyway, this is very, very important work to show the variability, but also which kind of vegetation and soil management and all this is included. Where we have touched these issues already today. But as a soil scientist also, I wanted to pick up these 3 points. And this slide before my closing. I wanted to show this because you know this mini racetron data. I learned that 30 years ago at your Michigan State University as Professor lab. So we repeated these studies in Finland, and here you can see my point. These are winter crops. There are wheat, rye, red clover, and timothy. From April to August, you see the hybrid dynamics. High dynamics, temporal dynamics. When they are at antithesis, the rooting is at maximum, and then they will decay. So these dynamics should be also taken into account, and of course there are then the differences between biomass input. I have also one other paper with spring sown cereals and ryegrass. And when these spring sown cereals rooting decreased, so the ryegrass, oh, you can, okay. It continued, the ryegrass rooting continued. So I have data on that too. So this is really important when we try to figure out all these carbon inputs by our cropping systems. But now we go back to the healthy soils. And well, I have learned that we need to take care of soil productivity, biological status, physical status, almost first, because if it's too wet, it won't have air to breathe, and so there is nothing gross occurring then. So we start maybe of soil pores and water management, and then biological state and chemical state. So all these are needed, and I'm very happy that in our mission text, this is repeated. All these three states of soils to be fertile and health and to remove carbon, to mitigate and adapt to climate change. Thank you very much.